Imagine you open up your math book and see a problem with numbers, fractions, variables, and it looks like a total mess. You think, multi-step equations? No way, I'm never getting this. But here's the secret. Every complicated equation can be untangled with simple recipe. Today, I'll show you how to break down the chaos into 6 clear steps that work every time. Whether the equation has fractions, parentheses, or variables on both sides. I'll even share the most common traps to avoid so you don't get stuck where most people do. By the end of this video, you'll turn those so-called impossible problems into easy wins. Ready to make multi-step equations simple and maybe even fun? Let's get started. My name is Mahmoud Kiasari. Welcome to Special K. Hello everybody, hope you're doing well. My name is Mahmoud Kiasari and welcome to Special K. Today we are at the second part or second chapter of module 4. We are going to solve only examples, try to review a couple of things related to the last module. For some of you that haven't seen that last module yet, I really recommend you to go after that, try to completely understand it, what is going on. We also talked about different conditions. We talk about the 6 step recipe that you can use in order to solve your equations. And also at this point, we are going to review everything again by focusing more on some kind of examples itself. So let's start from the beginning. At this point, I do have 2 equations and I would like to answer those. So the very first thing that I recommend you is that pause the video, try to solve these 2 answers based on your common knowledge, based on the knowledge that you have right now. And after that, try to go over it with me so we can understand that what your problem is. You can comment for me, and after that you can maybe just send an email to we can discuss more if you have more problem. If I see that some of you, most of you have problem with this section, I probably make another video about that. So without further ado, let's just talk about it. So at this point I do have a question. 4 times y minus 3 plus 5 is equal to 3y plus 10. So this is one of those equations that we do have it actually is going to be more than 2 steps, because if you remember we had 1 step, 2 step equation, and at some points when we do have variables on both sides, the situation is going to be a little bit challenging. It means that at first I have to try to get rid of all of the parentheses, all of the fractions at the beginning. After that, try to isolate all of the variables in one side and move other numbers to another side. So what do I have at this question? At this point I do have my 4y times my 3. The thing that I'm telling you is that try to start with the first recipe, with the first step of the recipe. It means that the dispute rule, it means that a times b plus c equals ab plus ac itself. So remember that. So what do I have at this point? I do have 4 times y subtracted by 3. It would be 4y subtracted by 12, 4 subtracted by negative 3 is 12, plus 5 is equals 3y plus 10. So it means that right now everything is okay. And also another rule was that using the like terms, it means that when you have like terms, try to add them up, try to sometimes subtract them, try to whatever do that you can do in order to simplify them. So you have negative 12 and 5 and negative 7. So at the end you have 4y subtracted by 7 is equal to 3y plus 10, right? So at this point I have to make sure all of the y's are on one side. So I'm going to use the reverse operation, and again I'm doing it for both sides because I have to keep the balance itself. So I do have 4y subtracted by 3y subtracted by 7 equals to 3y subtracted by 3y plus 10 itself. This one is going to cancel out this one. 3y subtracted by 4y, or 4y subtracted by 3y is going to be y itself. So I do have y minus 7 is equals to 10, right? I'm looking for y, so I have to move this y to the right side, add with 7, add with 7. So I do have y is equals to 17. Also, the last step I told you is that try to check or try to sanity check your answers. It means that whatever answer you found, try to put it in your equation to make sure the left side of equation, which is the first expression or LHS, is going to be as the same as right side of expression or RHS. So what do I have at this point? I do have my y right now, right? So the y was what? 17. So let's put it over here. If I put 17 subtracted by 3 is going to be 14. 4 times 14 is going to be 56, plus 5 is going to give me 61 for one side. I do have 3 times what? 3 times 17 itself is going to be 51, and if I add it with 10, I do have 61, so I know for sure that the answer is right again. So at this point, I do have a fraction. So as I just told you, whenever you see a fraction, it doesn't matter how many number of fractions. For example, at this point, we do have 3 fractions. Try to find the least common denominator. What is the least common denominator? It's the least number that actually can be divided by all of those numbers evenly without having any remainder itself. So right now, I do have 5, I do have 2, I do have 10. So if I told you, in order to find the common denominator, try to divide down your number into prime factors. 5, you just multiply by 1, which, I mean, 1 is not going to be considered a prime factor, so you just get me the 5 itself, 2, and this guy is 2 multiplied by 5. After that, try to find the common numbers between your numbers and try to write them down by considering some kind of the most power. So at this point, I don't have any common number between all of them. So at another point, try to consider the uncommon number. So what is the uncommon number between all of them? Actually, it is 2 and 5. So I can consider 10 as my LCD. I know for sure 10 can be divided by 5, by 2 and 10 without any problem or remainder. So right now, I have to multiply both sides by my LCD, which is 10. 10 times x over 5 subtracted by 1 over 2 equals 10 times 7 over 10, right? So again, this distribute rule. So I do have 10 times x over 5. 10 divided by 5 is going to be 2. 2x subtracted by 5 equals to 7 itself. I know how I'm going to do that because it's a two-step equation, plus 5, plus 5. So I do have 2x equals to what? 12. So x is equals to 6. Why? Because I have to divide both by 2 itself. X is 6, and if you put that one over here at the end, you will see that 6 over 5 subtracted by 1 over 2 is equals to 7 over 10. Simple as that. So we do have another kind of practice over here. This is some kind of standard level. Again, try to pause the video, think about it. After that, we are going to go over all of the questions one by one together. So at the very first point, I do have this question. It would be better to write it down because this form is not very good. So I do have 2 over 3x, or I can write it down as 2x divided by 3. Again, doesn't matter, I can do that. Subtracted by 5 over 4 equals 1 over 6 times x plus 9. So how many fractions I do have? 3, 4, and 6. So I have to find the common denominator between them. 3, 4, 6. 83, 2 to the power 2, 3 times 2 itself. What is the common number between all of them? So we don't have that, but we have to use the uncommon number with the most number, or the biggest number of power. 2 to the power 2 times 3. It could be what? 12. So 12 is the LCD itself. So I have to multiply both sides by LCD in order to make sure that these fractions are going to vanish. 12 multiplied by 12, multiply everything by 12. So what do I have? I do have 12 times this guy. I do have 12 times this guy. It would be 12 times 2x divided by 3, which 12 divided by 3 is going to be 4. 4 times 2 is going to be 8x. So I do have 8x. After that, let me make it a little bit bigger. I do have 12 times negative 5 over 4. Remember, you have a negative sign. 12 times divided by 4, 3. 3 times negative 5, negative 15. After that, I do have 12 times the whole thing. The very first thing that I have to do, I have to multiply 12 by the coefficient, which is 1 over 6. 12 divided by 6, it would be 2. So at this point, I do have 2 times x plus 9. After that, I know for a fact I have to get rid of what? Get rid of the fraction itself. 2 times x, 2 times 9, 2x plus 18. So the right side is 2x plus 9, 18. The left side is 8x minus 15 is equals to the right side. So at this point, I know for sure I have to get rid of one of those x's, either 2x or 8x. So I actually moved it to another side because I would like to isolate it, right? So subtracted by 2x, subtracted by 2x. I do have 8x subtracted by 2x, subtracted by 15 equals, this guy is going to cancel out this guy, 18. I know 8x and 2x are two like terms, so I can write it down 6x minus 15 is equals to 18. So if I have to move the 15 to another side, plus 15, plus 15. So I do have 6x equals to what? 31. So x is somehow equals to what? Equals to 5 itself. And if we use this 5, we see that the left side of the equation is going to be the same as the right side. So what do I have over here? I do have 5 times 2 minus 6 is equals to 3x minus s. Isn't that kind of hard question? Distribute rule, this one. So what do I have? I do have 5 times 2, 10, subtracted by 5x is equal to 3x minus 8. So I have to, for example, move this 5x or negative 5 is over here, plus 5x, plus 5x. What do I have? This is going to cancel this down. 10 equals 8x subtracted by 8, right? How I can move the 8 over here? Plus 8, plus 8. Inverse operation. 18 is equals 8x, and x equals 18 divided by 8 itself. So for the next question, it's not that kind of hard one. I would like you guys to write me down on the comment itself what is your answer and try to explain it why for me. After that, we do have some kind of challenging question. Again, try to stop this video, try to solve them, and I would like you guys to solve this question itself. Again, it's not that hard question. You do have the LCD, you have the LCD in order to get rid of that. After that, just about the multiplication and try to rearrange it, and that's it. We do have the same question over here. Try to solve this and try to comment me down below. After that, we do have some kind of error hunting, because as I just remember, I told you that it is so easy to get lost. It means that we talked about a couple of errors for the last video, that at some point when you try to solve questions, you are going to face a problem. For example, you're going to be missing a sign. At some point, you're using the LCD, but you forgot to multiply both sides by itself, and anything could happen, right? That's why we do have the sanity check. We do have the last step that we have to make sure that the answer that we do have is going to do something with the left side of the expression that give me a number, that number is going to be as the same as the right side of the expression itself. So at this point, we are going to find that error itself. So what do I have? I do have x over 4 plus 2 over 3 is equals to 5. So obviously, I have to find a common denominator. The LCD is 12, right? Multiply the first term, 12, by x over 4, I mean something like this. The 12 should be multiplied by this side, the whole thing, and 12 should be multiplied by this side, this is the whole thing. So I do have 12 times x over 4 is equal to 3x, easy. After that, I'm going to multiply the 12 by the second side is 2 over 3, and I do have it as 8, right? So in a step 4, I do have 3x plus 8 is equals to 5. So as you can see over here, something just happened. What? The thing that happened is I found the LCD, right? I multiply everything by LCD on the left side, but I completely forgot to do the same thing on the right side. Instead of just having 12 times 5, I just have the 5 itself. So what would happen? I do have 3x plus 8 is equals to what? Is equals to 5. So I'm going to solve this question, and 3x plus 8 equals to 5. I'm going to do it, and at the end I would have x is equals to -1. Voila! I do have a very, very good answer, but I will forget to what? To some kind of do the sanity check, and at the end I have my mark and say that, oh my god, what did I do wrong? So as you can see over here, we had a problem. But at some point you can understand the problem at the moment, but at another point you have to remember all the time for the sanity check. So imagine at this point we do have the -1 itself, so I have to check whether this answer is not right or not. How I can check that? X over 4 plus 2 over 3 should be 5, right? So x, using the substitution method, I do have -1. So -1 over 4 plus 2 over 3. How can I find it? Again, use the LCD itself. The LCD is 12 and 12. So 4 just became 12. -1 should be multiplied by 3, -3. 3 just became 12. 2 times 4, I do have 8. So I do have 5 as over 12. So as you can see, obviously 5 over 12 is not going to be as the same as 5. So for sure, I know I did something wrong. So this is the way that you can understand whether you did the answer right or wrong itself. So this is the sanity check, as I just talked about this one. So at this point, we do have a question. We have to make sure that how actually, or what are the steps about the sanity check. So for the sanity check, we do have 3 things. The first part is the substituting method. It means that instead of just the variable itself, I have to just I have to write it down my answer. And LHS, or the left, something that we call as the left side, should be as the same as RHS, or the right side. It means that after we just kind of substitute our answer instead of x, we have to return to the original question or equation itself, substitute your values into every x, calculate the left side, and also using the PEMDAS or any kind of method, calculate the right side and make sure that LHS and RHS are going to be right or not. Also, you remember about the domain check. It means that at some point we do have what? Undefined values. What was undefined values? The undefined value means that you have a fraction that in denominator, instead of just any number, you just have 0 itself. So if you remember, I told you that whenever you have 1, for example, over 1 over x minus 3, for sure you know that x is equal to 3 is not going to be your answer. It doesn't matter at the end you found x is equal to 3, but you know for a fact it's not going to be answer, because as soon as you x equals 3, you're going to have some issues with the whole thing itself. So this is the 6th step of recipe that we were talking about it. Again, we do have the distribute terms at the first point. We have to get rid of fraction using distribute method. After that, we do have the combining the like terms. And after that, we do have the moving terms, because I told you we need to have all of the variables in one side and all of the numbers on the other side. Multiply by LCD if you have the fraction itself. In order to get rid of that, isolate the variables. It means that move all of the variables in one side and numbers on another side. And at the end, you have to substitute your variable with the answer that you had in order to make sure your answer is going to be right itself. So for the last part, I just do have a very, very quick quiz for you. You guys can solve it. It's not that hard. Again, try to some kind of think about it and comment in the answer down below. If you have any problem, I will go over all of this question again in another and separate video for you, to make sure that you completely understand all of those. So after that, that was the end part of this chapter. Again, it wasn't that kind of big one. So again, at this chapter, which is the module 4 or chapter 4, we were talking about some kind of the messy equations when we do have some kind of when we do have the variables on both sides, and when we do have to deal with the fraction itself. Try to again rewatch this video, try to rewatch the previous video, and again, if you have any problem with any part of the thing that I was talking about, you can look over the channel. I had so many videos about all of these terms, all of this some kind of meanings, and you can rewatch it again if the problem insists and say consistent. I mean, you still have the problem itself. You can ask me to make another video for you. Please like, share, and comment this video if you found it helpful. My name is Mahmoud Kiasari. I wish you have a great day, night, whatever. See you around.